Hey, this is OXDF, and today we're diving into the mailroom box from HackTheBox, and specifically we're looking at a step that involves tracing a KeePass CLI process. So there's this step in the box where I have access as a user called Matthew, and Matthew can access a KeePass database. Unfortunately for me, I don't have the password for it, and I can't crack the password for it. So I'm kind of stuck there. But if I look at the process list, I'll notice there's another user, like presumably the real Matthew, running KeePass CLI to interact with the database. And the box is configured such that any user can trace processes from the same user. And so to solve the box, I'm going to attach to the legit Matthew's process and use strace to watch the system call showing the password being input, and I can grab the password. There's this weird thing though. So like if I attach in, the process starts, runs for a little while and stops. And if I attach in the middle of it, I might get the middle of the password, and that's not what I want. So I want to get right at the beginning, right? So to get attached to the beginning, what I do is I start a loop that watches for the new process to start and then attaches right away. And unfortunately, within like a few seconds before anything prints out, I get cut off and kicked out, which is really curious. And it's not hard to overcome. In fact, I can just add just reattach right away and I get everything I need. But I want to look at the automation and try to say like, well, why is this happening? So that's what we're going to do in this video is we're going to just dig around and look at the automation a little bit. So let's go ahead and jump in. I'm sitting here with my root shell as Matthew. I'm actually going to drop to a shell, or as root, I'm actually drop to a shell as Matthew so that I can show you kind of exactly what I'm talking about. We'll just do kind of the quick version. The box is running with hide PID, so I can only see processes running as the current user. So you can see actually there is a KP CLI process running right now. We're going to wait for that to finish. And when it does, I'm going to run, well, I guess we can do strace minus p, probably dead by now, but PID of Perl. And so that right there is failing because it's basically saying p takes an argument and this returns nothing because there is no PID of Perl. So if we can start to say like ps awx dub, and we can wait. It's back again. Okay, so we've run this, and boom, we're getting some stuff, right? But we jumped in right at the middle. I don't really know what we're looking at. I want to clean. It's loud, so what I really want to do is save this to a file and be able to analyze it. But I want to make sure I get the full process. So because we're on HackTheBox, I can start over. And so my first thought is, okay, I'm going to make a loop to do this. So I'm just going to grab. I have it over here in my notes. See, we can look ps aux dub. Let's make sure it's. We're going to wait a second until it stops running so that we can start when it's not. Oops. See, so you can see we have the KP CLI process running right here. Okay, it's good. So now I'll paste in my loop here, and what this is going to do is it's going to say while this is nothing. So while PID is nothing, do a sleep for 1 second, and as soon as I'm done, attach strace and to that PID. And this is what I get. I get strace attached, and then I start to get something, and then I get a breakpoint trap. I get a trap. So something is something is sending the signal to my process and then get out. So the way I solve this is I have a better loop, and this loop's even better because what it's going to do is it's going to while PID of Perl is something, it's going to sleep for a second. So it's going to sleep until PID of Perl goes away. Then it's going to wait for PID of Perl to come back, sleeping a second at a time, and then it's going to strace on PID. And as soon as it gets booted, it's going to strace on that PID again. And so if we run this, and really what I would do if I was doing this for real, I'm not just trying to show you, I would add a -o and put a file here so that I just capture all this strace junk to a file, and then I can go back and analyze it and figure out exactly what's going on. But for here, that doesn't make for a very good demo. So any second now, I would expect the process will start. Here we go. So there I attached. I probably got kicked out. There's my core dump right there, or there's my dump right here. I got trapped, and then I immediately attach again to the same process. And now you can start to see here's some read calls of P. It writes a P, it reads an E, it writes an E. So that's reading, and that is the user typing in the password to log into the KeePass instance. So that's pretty cool. That's what we got. But like that begs the question, like what's going on? So let's jump out of here. I'm gonna go back to my root shell. And as root, I can start to say, okay, how is this happening, right? I know there's not actually a real user typing this stuff in. So, the first place I'm always going to look is cron tab -l. And we can see that there's 2 cron tabs running here. Every 3 minutes, it's going to run this cleanup.sh. Probably not related. But then there's this kp.cli.sh running every minute. Perfect. Okay, so let's look at that. This is a bash script. It's going to check and see if the process is running. So pgrep, it's going to process grep Python 3, blah, blah, this script, a Python script. And if it's not running, if nothing comes back, then it's going to export term, and it's going to use nohup to start this process. With nohup just starts it in a separate place, basically unassociated with this process, not as a child. And then it's going to sleep for 30 seconds and do it again. So it's really trying to start this Python process a lot. Anytime, so every minute it's going to see, is it running? It's going to try to start it. It's going to sleep 30 seconds and try to start it again. So let's take a look at that process. Matthew, okay, there we go. Back up here to the top. Some imports here. Let's see. We're simulating Matthew logging into the database in real time. We got some variables defined. We have the send human function, and all this is really doing is basically saying, it's for each character, it's going to, we'll get down to it in a second, but K is a p-expect process. So p-expect is a way in Python, and actually it's a Linux thing as well, where you can attach to a process and programmatically send input and read the outputs. And so this K is going to send a character, and then it's going to have some delay for a random amount between 0.05 and a quarter of a second. So simulating a human moving around on the keyboard, right? So this send human is just a function meant to do that. More interestingly, so here we're going to spawn with pexpect as Matthew, the command kpcli. We're going to sleep for 3 seconds. We're expecting to see the kpcli prompt. And so we're going to wait until we see that prompt spitting out. Then we're going to come into this while true loop. First thing we're going to do is we're going to check the hash sum, or the hash sum, the MD5 hash of the DB, the path. Basically, they want to make sure that no other HackTheBox players mess with this thing, change the passwords, etc. And if it doesn't match, it's going to copy the original copy of it into Matthew's home directory and change it to Matthew. So that just prevents something messed with. Then it's going to check and see, like, is the process still alive? And if it's not, then we're gonna bail out of the script. And the reason we need to do that is because it's every 30 seconds it's trying to start the script again, but only if it's not already running. And so we want to, if we're dead, we want to get out quickly. Now this is the part that's interesting, and this is the part that caused the weird behavior. The comment says, kill other previous tracers to avoid people leaving strace or something blocking users from tracing. I'm not exactly sure what strace would block, but you could even attach to this with GDB, and you could really start to control and step through things. And if you once one person hooks in, no one else can do it. You can only have one debugger at a time. And so this is basically saying, let's go ahead and kill that. So what we do is we get the PID, we get the child's PID from kpcli, and then we're going to find anyone that's tracing that PID. And if the tracer PID is not 0, we're going to kill it. And that basically sends it by sending a -5, which is a sig trap, which is why we saw a trap when we got kicked out of the process. Then we have this, we open the DB path, we wait for it to say provide the master password, we type the master password, which is secure password, and then this is kind of a neat part. They've actually put this 1 as a typo, so then this \010 is the backspace key, so then you get the RD9. Then we wait for it to put that, and we go in and we actually do a show of the password, so presumably we could even get the root password out of that. So that's actually it. To me, I thought that was really interesting, and I was kind of curious as to why I was getting that behavior. And it's always interesting to look at how human behavior is simulated on HackTheBox. And if nothing else, you could learn like a new tool here. Like if you've not used pexpect before, it's actually really useful when you want to use processes. You can do sub-process, you can read and write to it, but it's very complicated and hard to do, and pexpect just works really nicely. So definitely a tool you might want to check out. Even not for if you're making a box for HackTheBox, that's awesome. But even if you're just automating interactions with another process. So I'm going to call it here. Thanks for hanging out with me today, and I'll talk to you next time. Bye.